Hey class, this week we are finally going to be going over object-oriented programming. It's taken a while to get here, but we needed to make sure that you had the foundations of C++. Now we can kind of get into this new programming paradigm that is a little tricky to grasp, but I promise you, once you get it, it's going to make coding so much easier and so much more organized. There's a lot of things that we need to cover. So it's going to be probably a longer video. I'm going to do some live coding in it. Um, a lot of vocab. So I highly recommend you guys get out a pen and paper and write these things down because I'm going to start using this verbiage going forward. So I expect you guys to get familiar with some of these words that may seem a little foreign to you. So yeah, classes, objects, encapsulation, header files. I mean, all this stuff, constructors, attributes, and methods. All of these, they're not too hard, not too crazy, but they are probably unfamiliar to most of you. So the first thing I want to go over is a header file. Secretly, or maybe not so secretly, this entire semester so far, I have been using header files in the background of all of your code. And it was to help me create those test files so I could test your code, run it through a lot of those test cases that we've been doing. Now you get to know what they are, what they do, and you're actually going to be coding them yourself now. So a header file is a type of file. It has a different extension. Instead of being a .cpp, it's going to be a .h. And it's a type of file where you define or declare a lot of your code. So your functions, your classes, you would actually declare them in the header file. Now, the reason why you do that is, one, it's a good organizational tool because you will be, saving space in your main file. But also, the biggest reason is if you were to make another CPP file, you can actually call those same functions or call those same classes and create objects with them. And you can just reference that header file. So it's kind of like a central place where you can have multiple files kind of reference and borrow. Like I said, I've been using this so far to test because you guys will write a function. I have a header file in the background that's calling it, so I can call those same functions in the test file. This was our blackjack example. Notice this is your main CPP file, and we went over enumeration and structs and all this fun stuff. You have your functions here, but notice that in my includes, and you may have noticed this from the start, but in the includes I have this .h file, and if you look at the .h file, all of the functions and structs that we used in this file are being declared here in the header file. And so this is a place where my test CPP file would look and know, hey, they're using a struct called card, they're using these functions, these are their parameters, and it kind of knows where to look so it can access the meat and the potatoes of your code. Up here where you see some of this weird stuff, remember, whenever you see this little pound sign, this is a pre-processing directive. Sorry, let me zoom in a little bit. I just noticed probably kind of hard to see. So yeah, this is the .h file, CPP file. Anyway, this pre-processing directives, this is just telling you this just tells the file to go behind the scenes, know where to look, know what file it's grabbing. And you will always put this to start and then this at the end. You do the if not defined, if and def. And then right here, you put in all caps, you put the name of the file, and then instead of a dot, you put an underscore here. So infinite blackjack.h would be all caps and then an underscore. So if not defined, then define it. And then you have your header code information, and then at the end you put end if. All right. So in this course, the way that I'm going to be organizing things is you are going to be writing all of your classes in the header file. This is for two reasons. One, the organization part that I mentioned, but two, this is kind of the only way that my test files are going to be able to grab information from the class. So if I'm going to make some objects in my test files, you need to make sure that the classes are properly defined in the header. And, it's good practice. It keeps things organized. Now, the header file is going to be found in that include folder, that INC. So far, it is in that SRC, that source folder, is where you've been keeping your CPP files. You're going to continue to keep your CPP files there, but now you're going to go to that INC file is where you'll find that header. And you don't have to do this, but it's always good practice, and you will see this in this class. The header file will always be named the same as the CPP file. It will just have a .h extension instead of that .cpp. So hopefully that makes a little bit of sense. It's nothing too crazy or groundbreaking. It's just a central place where you can kind of declare some of the things in your code. Notice that when it comes to functions, notice that I didn't define what the functions did in the header file. I just defined their return types, their name, and their parameters. With classes, it's a little different. You're actually going to be defining the entire thing inside the H file. So there is a little bit of difference there. But other than that, it's going to be pretty much the same. Okay. Classes. So a class is the blueprint for your code. So similar to a struct, when we learned about a struct, we learned that it kind of it grabs this data and it puts different attributes together into one little structure, right? To a struct. And then within that, when you create something of that data type, you can go into that struct and you can kind of pick if we're talking about measurements or a person, person.height or person.weight, you can access, it's a person, and then you can access the different attributes within that. Classes are literally that same concept, but it's just expanded. It's to include a lot more stuff now that we can do instead of just having different variables. So I've thought through different analogies, and I think the best one that I've landed on, going kind of with the blueprint example, are houses. So let's say this is your room. Your room exists within your house, right? And your house most likely exists in a neighborhood. And if you live in a neighborhood like mine, a lot of the houses in my neighborhood came from certain floor plans. There was a blueprint that had, certain different cookie cutter kind of houses. Those houses were built off that blueprint, which gave me my house, and in turn gave me my room. So your class is going to be the track of homes that you are building. Every home is going to have, similar square footage, similar number of bedrooms and bathrooms, slight differences here or there, but the bulk of it is going to be the same. An object is going to be an instantiation of that class. It is going to be, pick one of these homes in this neighborhood, and that's going to give you your home here. This is your object. Now your object, your home, can probably do many different things. You have different bedrooms. You got Susan's room and Jack's room and Bob's room. You have the bathroom. You have the kitchen. And there's some flexibility there, right? Me and my neighbor, we have the same floor plan, but if I go into his house, it's going to look very different. He's going to have different furniture. There's different people living in that house. There's differences in there, but it still came from the same blueprint. And so within this object, within this object, you're going to have differences. You're going to have bedrooms, you're going to have bathrooms, all these different things that I just mentioned. And that's kind of the best way to think of a class. You are building a blueprint. And then you can use that blueprint to build different houses from that blueprint. Okay? Hopefully that makes a little bit of sense. So an object, like I said, it's an instantiation of that class. So you made your blueprint, and now you can call objects, or you can build different houses, and you can build as many as you want. From that house class, you've built Bob's house, Jim's house, Sally's house. These are all different objects, right? They're from the same blueprint, but Bob's house has different people living there. Maybe he took down a wall in his house and made his bedroom bigger. Jim's house remodeled his kitchen. Sally's house, she has a big playroom in the basement. These are all differences, but they all came from the blueprint. Okay? Now, this concept is known as encapsulation. So what you're doing is you're taking different functions, and you're taking different variables that are within that object, and you're kind of shoving them into kind of one source, into one object. That is called encapsulation, and that is kind of a pillar or a foundation of object-oriented programming. The whole point of object-oriented programming is to encapsulate your data into these reusable units that you can continue to call. So, I want to give you an example, but I kind of want to code the example. I'll leave these slides in here for your reference, going back to this, but I kind of want to code this with you guys. So if you just hang in there for 2 seconds, I am going to pull up my code. Okay. So, first thing is to go over where things are located. So this is going to look similar to what you guys get every week. We have our CMake. Remember, we don't really touch the build stuff. Files you don't need to worry about for a little bit. But we have this INC folder and this SRC folder. So first thing is, if I expand the SRC source, this is where my CPP file is. So I'm going to open that up. And then if you expand this include, this INC, this gives me the header. And notice that they're named the same, right? It's just one is a .cpp, one is a .h. So the first thing I want to do is I kind of want to set up my files, right? So let's set up my header file. And remember, the first thing I want to do is I want to put the ifn def, if not defined. Then in all caps, I want to put the name of my file, then I do an _h. So if testexample.h is not defined, then define it. Testexample _h. And then we have to remember, when we're all through, we go end if, just like that. Now, another thing you have to add in your header file is you need to add your other includes. So I want to include my IOStream, and for this demonstration I'm going to include string, and just for convenience I'm going to do using namespace standard. Right? So that's kind of the bulk of it, and now this is where you would declare things. So since we're creating a class, we are going to create our entire class in the header file. So my class name, I start with class. I'm going to name it house. It's good practice to always capitalize the first letter of your class. Curly braces, I'm going to put a semicolon there. And now this next thing I'm going to do is called an access modifier. So private, there's public, and there's actually a third one called protected. Protected we are not going to go over today. This is something we're going to go over when we're talking about creating multiple classes. So I'm actually going to delete this, but just know that an access modifier is going to be one of these three things. So what an access modifier is it tells your program whatever data that I am putting in my class, how is an end user going to access this data? Or how is the data going to be accessed from outside of the class? If it's public, that means outside of the class, you can grab it. There's no restrictions, there's no security. If I make a variable int height, then outside of my class, when I instantiate an object, I can call height all day long. I can view what the data is, I can modify the data, no biggie. But private means it can only be accessed within the class. So if I added int height right here, then within the class I can do that. I can view height, I can modify height, no big deal. But once I go outside of the class, it won't even recognize that the variable even exists. If I say, show me, the house object dot height, just like a struct, right? It would not recognize it because it's protected. Technically it's private, but what I mean is it's protected from an outside person to come in and to view it or modify it. So that's called an access modifier. Now, best practice is to put all of your attributes in private. And the reason why is you don't want to accidentally modify data. That can be really, really bad. An example I can think of is your bank account information. You work at a bank and you need to modify some code that goes over maybe customer's balance. And can you imagine if you accidentally added or took away a 0 to their balance? That'd be horrible. You'd probably be fired. So we do this to protect ourselves. If their balance variable was private, we couldn't accidentally do that. It would be very intentional if we did do that. So it's good practice to always put your different variables in private. So the first thing I want to do, and when we're thinking about our blueprint, our house, we want to think about different properties that this house might have, different features that it may have. So I'm first going to declare my attributes. Now, an attribute is just a fancy word for a variable. That's really all it is, but we just call it an attribute when it's within a class. So the first one I'm going to make is of type int, and it's going to be called square foot. So it's going to be the square footage of our house. I'm going to do another int. I'm going to call it year built. So what year was it built? I'm going to do a string. I'm going to call owner name. So who lives in this house or who owns this house? And then this last one, I'm going to explain to you in a second, but I'm actually going to do a Boolean, and I'm going to call it lock door. And this directly relates to a little function we're gonna create. And that's about it. These are my attributes. So these are the different, parts of this blueprint of this house. We have the square footage, the year was it built, who owns it, and then this, lock door thing, which I'll explain. So now let's go to the public access modifier. This good practice, once again, is to put something called the constructor in there, which I'll explain, and then your functions. Now, a function within a class is called a method. Once again, like an attribute, it's just another fancy name. But when we're talking about classes, we're talking about methods. So you're going to hear me interchange these words a lot. But, best thing for me to say is a method is a function within the class. An attribute is a variable within a class. So this is where we're going to build a method in here, and we're going to build something called the constructor. Now, the constructor is, it pretty much sets your default values every time that object is called. So, for example, if for whatever reason in my little subdivision, all of my houses were built in 2012, I could set that variable to be 2012 in the constructor. So every time someone creates that house object, it's setting the year built to 2012, no matter what. So these are some things that we can do. We can also require the class to have parameters. So every time you make a house object, you're required to put something in the parameters like it's a function. So the syntax for this, it will always be the name of the class. So capital H, and it's going to be house. Then you put parentheses here. Within the parentheses, this is where you would put any required parameters. So if you don't want it to have any parameters, you just don't put anything in there, just like a function. If you do want it to have parameters, you need to say you need to put variables for what these parameters are. So in my case, I want, every time we call a house object, I want to take these 3 variables and I want the end user to define what these are. So I'm going to do int, and you can name these whatever you want. I'm going to name it the same thing as our attributes here. So int square foot, int year built, string owner name, and I'm not going to put lock door in there. I'm just going to keep these 3. So then I am going to put a colon here, okay? And what I'm doing now is I'm going to set these default values. So every time a house object is called or created, what are these values going to be? Well, I just said I want these values to be whatever parameters the end user are putting in. So what you do is you put the name of the variable up here, and in parentheses, you're putting the value that you want it to be. So it's going to look like that. And then I'm going to do comma, year built is going to be the year built. And then owner name is going to be the owner name. Okay. Okay, this lock door. What I want to do for this one is I'm going to reference this variable. So lock door, but instead of passing it a value for my parameters here, I'm just going to set it to be false. So this means that every time a house object is made, these attributes up here are going to be what's passed in as parameters, except for this last one. This one will always be false. Okay? And that's a constructor. There is alternative syntax on how you could do these things. This is the more modern and more streamlined way. I'll let you guys Google how to do it the other way. But yeah, you're going to see this more often. Okay? There is another thing called overloading a constructor. I'm sorry, I forgot one thing. Once you do that, you need to put curly braces, just a start and an end. Sorry, make sure you do the curly braces as well. Okay, so now that you have a constructor, you can do something called overloading the constructor. So if you remember when we were talking about overloading functions a few weeks back, it's a similar concept, except it's with the constructor. So basically, I can do this again, right? Let me just show you for an example. So I just copied it again, but this time let's not take any parameters, and let's just set these all to be 0. And for funsies, let's set this to be true. So now with this overloaded constructor, if someone was to input parameters here, that's what the values would be. But if someone doesn't put any parameters, then the values are just going to be zeroed out. Right? So anyway, I'm not going to worry about that right now, but that is how you would overload the constructor. Okay, so we have our constructor. Now I want to create a method, and I'm just going to do one method for this class. It's going to be void, meaning I don't have a returned. I'm not returning any value. I'm just going to call it door. It's not going to take any parameters. And within it, I'm going to do if, and I'm going to do not lock door. So what I'm saying is, if lock door is not true, another way you could put this is if lock door is equal to false, right? But I'm going to say if lock door is not true, then I'm going to put lock door equal to true. And then I'm going to see out to the console. The doors are now locked. End the line. Oh, sorry. Else, so if lock door is already equal to true, I'm going to do lock door equal to false. See out. The doors are now unlocked. And I'm going to end the line. So what this method does is, I kind of pulled this out of my hat here, but the idea was, let's say you have one of those apps on your phone that locks and unlocks your doors. The idea was, you push the button on your phone, and it's going to say, hey, we just locked all the doors. Your house is all locked up now. You push it again, and you're like, oh, the doors are all unlocked now. So that was kind of my thinking to that, and that's what that lock door variable is. So it's going to start unlocked, I suppose, is the door. The doors are going to start unlocked. Then you click it once, and you've locked the doors. You click it again, and it's unlocked again. So that's it on the class. I mean, it's really simple, nothing crazy. Now let's go to the CPP file and show how we instantiate an object. So the first thing I want to do is I want to include IOStream, include string. Oh, and then this is really important. We need to include our header file, right? So test example.h. And notice that we put it in the double quotes here. We don't do it in those angled brackets when we're talking about our local header files. So you just put it in the double quotes there. And then using namespace standard. I'm going to do int main. Can't spell. Okay. So that's a little basic setup, right? Well, now what we're going to do is let's oh, why are you mad at me? Oh, okay. Just needed to save. So now we're going to call an object. So it's of type house, right? Because that's the name of our that's the name of our class. I'm going to call it my house, right? Now I got a red squiggly here. Why? Because no default constructor exists, I put parameters in my class. So I need to put parameters when I instantiate a new object. So I think the first thing I put was the square footage. Let's do 2,000 square feet. The second one I put was year built. Let's do 2015. And then the owner's name, Pierce Scott. Right? So now my house, I just set those variables. I have my square footage, I have the year as built, and I have the owner's name. Okay. So now, now that I've done that, let's use my method. So my house dot door, and then my house dot door again. So what this should do is I should lock my doors and then unlock my doors. Let's build. And there you go. The doors are now locked and the doors are now unlocked. So I locked my doors, then I unlocked my doors. So yeah, really simple, right? Now you can do this. You can do house Bob's house, and his house is 1995. It was built in 2017, and Bob. So now when I call the Bob's house object, it has these values. But when I call the my house object, it has these values. So I can do that as much as I want, and the values and methods are going to be contained within that object. All right, hopefully that makes sense to you guys. This is the very fundamentals of object-oriented programming. One more thing I want to go over, if we go back here, is remember I said that these are private, these attributes, meaning I can't really change them. To give you an example, let's take the square foot here. I cannot do my house dot square foot equals 50,000. I got rich all of a sudden. Notice I got a red squiggly here. And I have the red squiggly because it's inaccessible. Right here, inaccessible. It's a private variable, so I cannot access it directly. If square foot was public, then yeah, I could totally do this. That's totally fine. But since it's private, I cannot do that. So what if we do need to change the value? Do we make it public? Well, you could, but there is a better way. What you would do is you would make a special method, and we call these getters and setters. Now, they have these fancy names because they have very specific uses, but they're really, it's just a function, right? So what I would do is I'd write a new method. Let's do the square foot thing. It's going to be an int. It's going to be square foot. In fact, it doesn't even need to be int. Let's do void square foot. And all I'm going to do, actually, let's do that. Something silly like that. And we're going to do square foot equals x. And I should probably call this set. I can't name it square foot because we already have a function named square foot. So set square foot. And then square foot equals x. And we'll end it. So now, if you come here, I could do my house dot set square foot. And I could set it to be 50,000. I don't know why I put a comma there. And it should, if I didn't screw up, it should set that variable to 50,000. This is called a setter because I set the value to be something different. So now let's do a getter. So a getter would be you just view the value. So let's do void again, and we'll call it get square foot. And then this one, you shouldn't have to pass in anything. And you just do cout square foot. Just like that. So then right here, I can do my house dot get square foot. And then let's do it right before as well. And I messed it up. Okay, so what we should do is I set it to 2,000, right? So it should say 2,000, then I set it to 50,000, and then it should say 50,000 if I didn't mess up, right? Right here, okay, so the doors are locked, the doors are unlocked. 2,000 and then 50,000. So right here, my setter worked and my getters worked. So that is a safer way to change and view your private attributes. Okay, so I really want you guys to get in the habit of doing getters and setters, and then putting your attributes private. Okay, that should be just about be it. Please look over this, study this again. I have all these examples here. I didn't put getters and setters in it though, but everything else should be here. Please study it, And good luck on the homework. Please, once again, let me know if you need any help. And good luck.